and welcome to my talk. So I was having a hard time between the title because everything sounds cool in here. It's like NoSQL, not all data is created equal, or should I use SQL? Just think about it. Maybe we'll take a poll at the end of the talk. Hey, this is me. I'm a Microsoft Azure MVP. Also, I run the Orlando.NET user group and Orlando Code Camp, which is March 30th, so please sign up. I expect to see every single one of you there. I'm an Azure consultant at Nebiotech, and if you ever want to reach out to me, probably the best way is Twitter. You'll probably get a reply from me. Just don't troll me on there. And like they said, I've been in the software industry for over 20 years, so this is what I feel like these days. So we're going to have a little bit fun with this talk. This is one of my favorite talks. So what I want to do with this talk is I want to talk about from the perspective of someone who has not used too much of NoSQL databases experience. So you'll ask the question, I've always used SQL, so why not just continue using that? So that's question number one. We'll try to answer that. We'll talk about the basics of NoSQL, and I call it the CAP 3, just to make it easy to remember, and we'll jump into that. We'll talk about some of the different families of NoSQL and how they relate to what you're trying to do. We will talk about how not to become a news story or how not to show up on TechCrunch for the wrong reasons. So that's in here. And finally, I will talk about how to pick a managed or cloud-based NoSQL provider, which I highly recommend, by the way. If by the end of this talk I have not convinced you, please come see me and I'll convince you. So what is NoSQL? Okay, who here has used databases? Who here has used a relational database like SQL, MySQL Server? All right, good. Who here has used a NoSQL database? All right, so who here has used more than one NoSQL database? All right, all right. So I think this is the right audience for me. So NoSQL, and this, I'm not trying to define it. I'm trying to just clarify the context I'm talking in. I'm talking about a database that is largely non-relational, but that is a little bit debate. I have a little bit of debate about that, internal debate, and you'll see why. We're talking about a database that has flexible schema. So it means that you can throw in a person record and you can throw in a company record, and it should really be able to store both. There's no and you can throw in a person record with 3 fields, and you can throw in a person record with 20 fields, and it should be able to handle them. I'm talking about a database that stores massive amounts of data, aka data on scale. And it stores structured and unstructured data. So that is I'm just setting the ground rules of what my definition of NoSQL is. So why not SQL or why not SQL? I'm talking about, when I say SQL, I'm talking about relational databases, right? And these are things like MySQL, SQL Server, or Postgres, things we are familiar with. And this is because we'll be discussing some issues with SQL databases in particular. So when I say SQL databases, I'm talking about relational databases, all right? So the first thing, relational databases are always normalizing. What does that mean? So for instance, this is raw data. You have the record for a person which has name, skills, and experience. This is an extremely raw format, right? And what they do is, when we work in relational databases, we normalize it. We take the record and we break it down into tables that go user table, skills table, and experience table. Now, keep in mind that this is normalized, all right? So we talk about the first normal form, and second, and third, and you'd think that this is done, but it's not really done, because you still have this company here that could go into a different table. So just a single, simple piece of raw data, you can see that it's already gone across 3 or 4 tables. And Boyce, there's something called BCNF, a Boyce code normal form. And you can keep going. It's like there's a 4th normal form, 5th normal form. So soon they'll have newer ones. So either way, it keeps getting split up into smaller and smaller units. So what does this mean? We took a simple raw data record that belongs to a single person, and then we said that we're going to split this up into tables, right? So what did I just do? I took one record and I pulled, for one record, I need to pull 6 rows from 3 different tables, right? So I have to split it up and store and then pull it back in and assemble it. So this shredding, this is called shredding of data, or it's also in computer terms called impedance mismatching. It's a very common term, which means that the input and output are not quite matched. So you have like one record, and it's 6 rows across 3 tables, actually 4 tables and 8 rows or something of that sort. So this is just one of the issues, and we'll talk about other issues. But this is where a NoSQL comes in, and you can fetch all of those 6 rows of record. Instead of doing that, you can pull it in a single fetch. And that's kind of the appeal of NoSQL. What happens is when you try to take, this is just one simple example, right? In normal line of business apps, you'll probably find that you have 20 different tables for one simple user record. And you're trying to assemble and disassemble record. And when you do that for billions of records at scale, it starts to become really inefficient. So that is one of the things that we're trying to avoid with by using NoSQL databases. So with NoSQL database, you take one record, you put it into JSON format, and you store the JSON format in a table. Now this is an example of a document database, document NoSQL database. You have other types of NoSQL databases, which we will talk about shortly. But again, what we did was instead of splitting this up across 6 or 8 or 10 tables, we simply composed this into a simple JSON document, and we stored it. And so the write is one operation, the fetch is one operation. So the scaling part becomes really easy when you do this. Now, of course, there's disadvantages to this. Relational databases, obviously, when you normalize it, it reduces redundancy, and you have other things like that. So, and we'll talk about the trade-offs in a few minutes. So anyway, this process is called denormalization. So relational database, normalization. NoSQL databases, denormalization. Those are the advantages and disadvantages of both. That's the type of trade-offs we make. NoSQL systems are distributed. So you have an application. The application writes data to the database. So how NoSQL works is, as the data increases, instead of scaling up the database, it scales out. It adds one more node. So when it exceeds a certain threshold, what it says is, I'm not going to increase the disk space or the RAM on this machine. I've configured this machine to perfection for performance. So instead of increasing this, I'm going to store the data onto rest of the data on a different machine. So it keeps adding nodes. And what this does is a couple of things. Number one is, because it's storing nodes across on storing data on multiple nodes, there's not a single node like a SQL database. This is highly fault tolerant. So if one node goes down, the database should still continue working. So there's that advantage. And then the other one is scalability. When you have one machine and you scale it up, you can only scale it up so much. It is constrained by the laws of physics. And with NoSQL, that is, you're trying to kind of cheat physics by scaling out. So you can scale out far more than you can scale up. So that's one of the advantages of NoSQL databases. So, you keep adding nodes, and you keep adding them. So I wanted to talk about the basics of NoSQL databases. And I use a simple memory trick to remember them, call it CAP3. CAP is the CAP theorem, and 3 stands for 3 V's. And I'll jump into this in a minute. CAP theorem. So what is CAP theorem? So we have 3 different cases that happen. NoSQL databases, obviously, like I showed in my previous slide, they store data across multiple nodes. This means they're distributed systems. So distributed systems are governed by this law called Brewer's theorem or CAP theorem. And this there's 3 aspects to this. Number 1 is consistency. Relational database are ACID, which means that atomic, consistent, isolated, and durable, if I'm getting those right. So relational database are consistent, which means that when you write something, the next read should reflect that write. So let's say you have a banking record, and my banking balance says I have $110, and I add $10 to it. All the reads after that would show $120 because I added 10. So that is consistency. So number 1 is if you require a database to be consistent, a read should be guaranteed to return the latest write value. Availability. So availability is the fact that you spread it across multiple nodes, and so stuff happens. It's networking, it's computers. So what happens if a node fails? Availability guarantees that despite a failing node, it will return a valid value, and it won't return an error, or it won't return timeout or anything like that. So that's, if a system is available, then it means it will return something. Partition tolerant, and that's the third one. This, again, it comes from distributed systems. NoSQL databases, they're stored on multiple nodes. These nodes could be across data centers. They could be across machines in the same data center. They could span data centers. They could span countries, or they could be across the globe. So in that case, what happens when there's a fiber cut in one data center? And trust me, we live in the US, so we are very spoiled by this. And fiber cuts are common, and fiber cuts for internet connection are common in different parts of the world. So you have to account for this. So partition tolerance says that if there's a fiber cut, it'll still continue working in. So that means it's partition tolerant. So together, that's CAP. That's what the CAP theorem is. It's consistent, availability, and partition. And basically, the reality of this is that a system, if it's partition tolerant, the theorem states that if it's consistent and available, it cannot be partition tolerant. So you start to get into trade-offs. So what you're doing is, you're saying that I want to be able to scale my database on a massive scale. And for that, I'm saying that if it's partition, if it's consistent and available, the partition tolerance part won't be satisfied. Or if I decide that I want my database to be available at all time, and it's tolerating partition tolerance, it won't be consistent, which means that if I write to a node in Asia and I try to read the value in the US, if there's an issue with availability of partition tolerance, it won't show a consistent value, right? So, and same for availability. If it's consistent and partition tolerant, it won't be available. So that is the CAP theorem. It's basically a trade-off. However, there is a theorem which is theoretical, and there's reality. And the reality is that you always have to account for partition tolerance, because there is going to be a node cut, there's going to be a fiber cut, or some kind of latency issues when you distribute it across the world, across the globe, across data centers. So in that case, we say that I'm going to make my database consistent and partition tolerant. So in that case, what happens is, let's say I have two nodes in different data centers, and there is a issue with there is a network issue. So this means that this has not updated to my bank record has updated in US, but it's not updated in Japan. When someone tries to read from Japan, it's going to give an error. And it has to return an error because the data has not synced across the globe. So this is the first reality of partition tolerance, which is I can make it consistent and partition tolerant, which means it's not available at all times. This error means it's not available. Or the second reality, I want to make it available at all time. Again, there was a partition at some point, and I updated my bank record, and this is US was updated, Japan was not updated. But I want my system to be available, right? So when I go and read, let's say my client is in Japan and they hit the database of the Japanese side, it will show an old value. So that's not consistent. So that is CAP theorem, and that is one of the primary drivers behind NoSQL databases. The second one is the three part, which is the three V's: velocity, volume, and variety. And I will say that a lot of times you will be forced with this, or you'll have to decide between a SQL and a NoSQL database. This is one of the criteria that you can actually use to determine if you want to use a NoSQL database or not. So you can measure data in three different planes. Let's start with volume, right? So I have, starting at megabytes, gigabytes, terabytes, and petabytes, right? As this volume starts to increase, you should consider using a massively scalable database to handle that volume. And most likely it's going to be a NoSQL solution. Now this diagram is from 2015, and our database storage our data storage in databases has increased so exponentially that we now have a new value called zettabytes, I think. So this will keep on increasing. So as this starts to get into the outer rings, you may want to consider a NoSQL database. Velocity. So the number one driver for this is, you have batch data, okay? So I collected data from, logs or something like that, right? But as you start to get to the outer rings, you see real-time data. This often comes from the realm of IoT. Internet of Things. As you have sensors, millions of them, they send data, and that's real-time data collection. So if you have large, data coming in at high speeds, that's velocity. And so as you start to get to the outer rings, near real-time and real-time, you probably want to start using NoSQL database. And finally, variety. So let's say I have all text files, right? And all I'm doing is processing these text files. Now compare that with modern systems, which have all kinds of files like text, JSON, audio files, video files, photographs. So, and you have all kinds of unstructured data coming into. So as the variety of data starts to increase, or not just the variety of file formats, you can also look at things like, so I'll give an example of how I chose a NoSQL database at a previous project. So I was working on this project where we used to collect data from networking devices, right? And this networking devices are out in the field. What I realized that, even though I got sensor data from these networking devices, as you start to change the type of device, so let's say you went from Ubiquiti to some other brand, the type of data that they sent was completely different. And I didn't know how to handle this with a relational database. So that's when I chose a NoSQL database. So variety is not just the file formats, it's also the variety of schemas, a variety of the actual data format. So use this as one of the deciding criteria on if you want to choose a NoSQL database or not. Families of NoSQL, you have document-based NoSQL databases, for instance, MongoDB, graph, NoSQL databases, Neo4j, KeyValue, Redis, column-based, which is Cassandra. So if you ever hear about these type of databases, you can use this as a disambiguation matrix. Document databases, the database is stored as a JSON document. So for instance, this boarding pass was converted to this document database right here. So it's very readable, extremely readable. JSON is the language of the internet. And so large document databases are probably the most popular format of NoSQL database used by developers, right? Graph database. This is my favorite type of NoSQL database. And this is why I put the thinking symbol on the relational bullet on the first slide. Because I say NoSQL databases are non-relational, but graph databases are super relational. In fact, they are far more relational than a regular SQL-based relational database can be. So in this instance, you can see that the two person records have slightly different formats. And you can see that, excuse me, so these are called vertices. The round entities are called vertices, and they actually represent entities. The arrows are called edges, and they represent the relationship between entities. So this makes it really easy to add and remove relationship between this. So, for instance, James loves Mary, Mary loves James. Or tomorrow, if Mary decides to break up, they can remove this in one direction, and that would be a breakup. So it can also show complicated relationships real easy. KeyValue databases, it's a simple hash table type structure, key-value pair type structure. So you can store strings, you can store geospatial indexes, you can store numbers, you can store bitmaps. So key-value databases are the simplest form of database. Redis is a great example of this. Excuse me. Column databases, The difference between a column database and a regular table-based database is that in tabular databases, you store data by rows. In this, you group the data by columns. The advantage of this type of database is that it's really good at aggregating things. So let's say you want to calculate all the visitors for a particular website, right? And you want to calculate them based on IP address or something. So I can group by IP address, and that helps me, that will store all the data that belongs to a particular IP address on the same partition or in close proximity to each other. This makes running aggregation queries really efficient. So this is why you use column-based databases. The cloud. So we talked about the most common types of NoSQL databases. Now, how does this relate to the cloud? So let's say I want a document database. If I go to Microsoft Azure, this is the document database over there. Amazon DynamoDB is the document database. Google seems to have a couple. Honestly, I've never used anything but the first two. But again, if you're in the Google world, this is what you probably want to use as a document database. For graph databases, Amazon has Neptune, and Azure has a Gremlin-based API. I don't know one for Google. Maybe there's one, and someone will correct me over here. KeyValue, Amazon has DynamoDB works as a key-value pair. Google has memory store, and Azure has table API. And finally, column-based database. Google has Bigtable, and Azure has Cassandra API. So these are so as you start hearing these wide variety of data storage solutions, try to put them into these type of metrics, and that'll help you identify which type of database it is and what use case you can use them for. Okay, so first question. Should I switch from SQL to NoSQL? Not really. I mean, it depends, I guess. And second question, I can host my NoSQL server, right? And the answer is, I will always say no. You have to have a very specific set of skill set to do that kind of hosting. So again, when you want to answer, should I switch from SQL to NoSQL, you want to look at the strengths and weaknesses of each. So for instance, SQL is relational, NoSQL, in most cases it's non-relational or super relational, right? So let's say you want to enforce strict schema. You want to probably use a SQL database and not a NoSQL database, right? So just you look at the use case. Like there have been instances, like especially in the government type arena, where I have to enforce a strict schema. So I would like to use, I should probably be using a SQL database in that, or relational database in that instance. If I want to have ACID transaction, like let's say you want to do bank records and I want to increment and decrement, I don't want it to be weekly consistent. Like I don't want to like withdraw $10 and then still see the $10 in my account. So I should probably use a SQL database. So again, there's no switching, right? You want to probably use both of them. You want to use them depending on their use cases. So you should use both. And that's called, when you use multiple types of databases, that's called polyglot persistence. So that's, I always advocate for polyglot persistence. How am I doing on time? 10 minutes? All right, cool. That's okay. I think I'm going at a decent speed. I should be good to go. So this is my next one. And this often gets me in trouble at conferences. Like always have someone yelling from the audience or coming up to assault me after my talk. But I would say never host your NoSQL instance. If you look at the past year, and this is in the past 6 months, so MongoDB personal data for 66 million users. 11 million personal unprotected MongoDB instances. NoSQL data, NoSQL clusters are really hard to secure. The reason being, NoSQL clusters are, let's say you have a machine that's connected to the internet. It's really hard to secure by itself. You're talking about a cluster of thousands of machines across data centers, right? And I mean, you have, what I would say is that, and with all due respect to everyone in this room, including myself, it's really hard to do that for people working in, regular line of business apps. So if you're doing a line of business app and hosting a NoSQL is not your primary line of business, don't do it. Just don't do it. It's not worth it. You'll end up on TechCrunch. I'm sorry, what did you say?
What if you don't keep personal data on it?
Yeah, I guess suppose you could, if you want to expose your log data, go for it. I mean, I wouldn't stop you from doing that, but you still see.
Changes your data?
Yeah, no, I have a big database.
Right. So the thing is, it's all about perception, right? So even if you don't have personal data on there and your data got exposed and it's somehow you're not controlling that news and it gets out in the wild, your company or your employer still loses face for that. So just don't do it. It's not worth it. Don't do it. So what I would recommend is either use a managed or cloud-based hosting. And for cloud-based hosting, I showed, depending on which cloud, you can actually go and pick your variety of database. What I would say is, if you don't want to use a particular cloud, that's fine too. MongoDB, I think they provide a managed instance. So go with that instead. Seriously, don't do it. And if you want to pick so these are the factors you have to consider when you either pick a managed or cloud-based hosting. Security, consistency, latency, availability, global distribution, and total cost of operation. And I'll explain each one of these terms. Security, you want to ask these type of questions. Simple one, right? Is it HTTPS by default? That's the first one off the bat. Is it encrypted at rest? Does it support network and firewall security? If I'm doing an enterprise-y app, I want to somehow provide support for networks and firewalls, right? What happens when someone attacks? Is their platform able to monitor and respond to those attacks? And of course, if you're working with different government-type organizations, they're looking for these type of certifications. Does your provider do that? So, next one is consistency. So we talked about consistency. So strongly consistent means that when you write something and read it, it is able to show the latest, right? Eventual consistency is that when you write something, it'll eventually show up. An example of this is your Google Analytics, right? I don't get my Google Analytics for the last minute. I get it from almost yesterday. So that's an example of eventual consistency. So in most business system, when most NoSQL providers, they force you to choose between these, but cloud-based systems, especially by the big three, they have slowly started to drift to the center. So like some of them, for instance, Cosmos DB has this session consistency in which if you open up a connection and you write, you can read from that same connection. No other connections will be able to read it. So you get performance within your session, but you're still getting the overall fast availability that comes from the system. So again, you want to look for these type of flexible options. So the answer is somewhere in between. If it's only offering these two, then you probably want to look for other options. Latency, again, it's the start to end. When you do a write operation or read operation, the I/O that takes place, start to end of that is the latency. So if I do a read operation, I do the request, and I get the response, and this is the latency of the system. You want to make sure your cloud-based provider is providing latency in milliseconds, preferably single-digit milliseconds. Otherwise, you'll get a system that works like this. Availability. You hear about things like SLA 5 nines, 4 nines. So again, you want to always go for the highest availability. One trick to increase the availability is to deploy your NoSQL database to more than one regions in your cloud. So, for instance, when you deploy in one region, you get 4 nines availability. When you deploy to 2 regions, you get 5 nines availability. So that's how you do that. Again, you want to look for that in your cloud-based provider. Global distribution. Let's say you have customers all over the world. You want to deploy data close to them. So if there's a customer in India, I don't want them to come to the US to do reads, right? Or writes. So I want to deploy the database in multiple regions. So you basically your data all over the globe. Finally, total cost of ownership. If you look at NoSQL hosted on-premise, NoSQL on Azure virtual machines, the DynamoDB. This is from 2015. So before Amazon came out with DocumentDB, Azure actually had something called DocumentDB. They changed it to Cosmos DB, but that's a whole different story. So this is a study from 2016, I think. So if you look at the numbers for Amazon and Azure, you'll see that it's far lower. Why is this lower? Because they're considering total cost of ownership, and this includes things like a data center, electricity, people to maintain the database. With cloud-based providers, you don't have to deal with any of that. So your total cost of operation is much lower. So again, that's another reason you want to use cloud-based providers. In closing, I will read this quote from Maslow. This is the same guy who did the Maslow's pyramid of hierarchy, or whatever. Maslow's hierarchy, hierarchy of needs, So basically, if all you have is a hammer, everything looks like a nail. Don't use only SQL databases. Look to use NoSQL databases, aka polyglot persistence. So you probably want to use both. And never host your NoSQL instance. Please don't show up on the news for the wrong reasons. Thank you very much.